Okay. We are going to answer these set of questions for both of the graphs that you see on your worksheet. Okay, so first we will do it for what I've drawn in blue, the top graph. Okay, so it says, the first question 41 says, what is the minimum value of f of x? So what is the value speaks of a y coordinate. That's what we're talking about when they say value. The minimum value for this graph is 3. Okay, so that's this one. Number 2 is the most awkwardly worded question I've ever heard. And so I rewrote it. It says, for what value of x does f of x assume its minimum value? What they're asking is, where does the min occur? So I rewrote it as, where does the minimum occur? Where, right, this is the x question, so it occurs at x equals -3. You can write -3 or x equals -3. You can write y equals 3 or just 3. Either one of those is okay. Then number 3, how many real solutions are there to f of x equals to 1? Well, f of x equals to 1 is the same thing as y equals to 1, right? Y equals to 1. Well, y equals to 1 is a horizontal line. So what you want to do here, this is at 3, -3. Y equals to 1 is right here, down here at 1, right? How many places does the line intersect the parabola? 0. So the answer to this is 0. This marker's about gone, isn't it? 0. And then the next question is, how many real solutions are there to f of x equals to 3? Again, that is a horizontal line. Y equals to 3. So if we pass a horizontal line through 3, it's going to hit right here because this is at -3, 3. So how many times does the parabola intersect the line right there? 1. So there's one solution to that. And so let's go through and answer this green graph. Same questions. What is the minimum value of f of x? Well, the value is y, and so the answer to this is y is -3 or -3. That's how we'd answer the green question, the green graph. Where does the minimum occur? That where means the x. It occurs at 2, or you can put x as 2. How many real solutions are there to f of x equals to 1? Well, y equals 1 is right here, and it's intersecting 2 times, so there would be 2 solutions. How many real solutions are there to f of x equals to 3? Well, f of x equals to 3 is y equals 3, and again, there's 2 solutions to that. So that is helping us get used to the wording and what those mean, the interpretation of those questions. Okay, next we have curve fitting. It says, find the equation of the quadratic function satisfying the given conditions. And they give you some hints about that. And so let's look at 55. We have to write the equation of this parabola given this information. So 55 tells us the vertex is, this is 55. They tell us that the vertex is at the point -1, -4. And it passes through the point 5, 104. Okay. And then 56 is something similar. They tell us that the vertex is at -2, -3. And it passes through 0, -19. Okay, this is what they tell us. If they give you the vertex, use the vertex form. That is really awesome. So here's the vertex form. Y is a times x minus h plus k. Okay. So what does it mean, a working equation? What do we have to fill in? We have to put in a number, the right value for h, k, and a. And then we have completed what they've asked us to do. We've written the equation. So this, the vertex form, they gave me the vertex. So the x-coordinate in the vertex, this is h, and this is k. So already I've got y is equal to a. I do not know what a is, but I have x minus h. So x minus -1 goes right there, squared. Oops, I forgot my squared. plus k plus -4, or simply y is a times x plus 1 squared minus 4. Man, we are almost there. All we got to do is figure out what a is. And this is how we're going to do it. I have a working equation almost that describes all the points, and they gave me a point. This is an x value, and this is a y value. I'm going to substitute this in for my x, and this in for my y, and solve for a, and then I can figure out what a is. 104 is equal to a times x is 5 plus 1 squared minus 4. All right, so we have 104 is a times 6 squared minus 4. 104 is 36a minus 4. Add 4 to both sides. 108 is 36a. Divide both sides by 36. And I get that a is equal to 3. Yay, 3. Now we're going to write the working equation. Y is equal to 3 times x plus 1 squared minus 4. This is the answer to that. Let's do the exact same thing here. They gave me the vertex. Put it in vertex form. Y is equal to a times x minus -2, x plus 2 squared plus -3, minus 3. I put it in the, this, right here. All right, so then I'm going to borrow the point. -19 is equal to a, and I'm borrowing the point in order to solve for a. 0 plus 2, 2 squared minus 3. I'm going to add 3 to both sides, so that gives me -16 is equal to 2 squared, 4 times a. A is going to be -4. Y is equal to a, -4 times x minus h squared plus k. That's all you got to do. Okay, very last problem. Here we go. If you do not have your calculator, go grab it. You'll need it for this one. This is, they give us some information about how they form an equation that models something falling with gravity. And they tell you how to create it with this S of t. S is the variable we usually use to indicate motion, where something is, position of an object. So, it says if air resistance is neglected, the height s in feet of an object projected directly upward from an initial velocity s sub 0 feet with an initial height s sub 0 feet with initial velocity v sub 0 feet per second is given by this equation. Okay, so basically, since it's in feet, that -16 is the gravity force. That's where that came from. Okay. And so if it's in meters per second, you'll see -9.8. But since it's in feet, that's what it looks like. So let me just make a little space and we'll do this one. All right, here we go. So let's just think about it. They told us, number 66, they said, a toy rocket is launched from the top of a building. Oh, I have to draw a building. So here's the ground and here's a building. Let's make it here. There's a few windows in this. Sort of looks like a prison, but maybe it's a prison building. Okay, there's a building. A toy rocket is launched from the top of a building 50 feet tall. Okay, this guy's 50 feet tall. All right. With an initial velocity of 200 feet per second. Okay, so it's launched up, and we know about things, when you launch something up, gravity eventually takes over and makes it come back to Earth, unless it's launched out of our atmosphere, but it wasn't. It was still in our atmosphere, so it went up and came back down. Okay, so this is kind of what it looks like. And so here's my question. What is the initial position? How many feet in the air, off the air, is our rocket launched from? Well, if it's launched from the top of this building, the initial position is 50. So S sub 0 is 50, okay? And they told us the initial velocity is 200 feet per second. So V sub 0 is 200 feet per second. Now, something sub 0 means the initial amount, the initial place. It means when time is 0. So this is common to what we will use. Something sub 0 means where it starts from. So that's why they are using that. So let's write our equation. This is part A. Express the height S as a function of time. So if S of t is negative 16t squared plus the initial velocity, 200 times t plus the initial position, 50. This is an equation that describes our motion of this initial rocket right here. So that was part A. Part B says determine both analytically and graphically the time at which the rocket reaches its highest point. How high will it be at that time? Okay. Analytically, let's do that. Look here. This is the equation of a parabola with a leading coefficient that's negative, meaning it's facing down, meaning it has a maximum, right? And so, meaning it also has a vertex, HK. And the maximum will occur at the vertex. And this K value is the max value, the max height it's going to achieve. That's what it is. Well, we know how to find H and K. H is negative B over 2A, right? We know that. It's that little first part of the quadratic equation. So let's do that. H is negative 200 over 2 times negative 16. A negative over negative is a positive. If we take 200 divided by 32, what we get is 6.25. Now this is not the max height, this is H. And so let's think about our variable. This is, instead of X we have T, instead of Y we have S of T. At this T value, what is that T value? At 6.25 seconds, the rocket will be at its maximum height. And what is that maximum height? Well, we have to put this in our calculator. S of 6.25, negative 16 times 6.25 squared plus 200 times 6.25 plus 50. This is analytically what they mean when you solve it. You plug it in. And when we put all that in, we find out that it reaches a height of 675. That is our K value. So right here our vertex is 6.25 seconds. And the height is 675 feet. All right, so it reaches, let's see, the time at which it reaches its highest point, it reaches its highest point at 6.25 seconds. The highest point it reaches is 675 feet. All right, C, this is where we really want to use our calculator. For what time interval will the rocket be more than 300 feet above the ground? And so we're going to use our calculator for this, okay? So if this is 50 feet off the ground, and this is 675 feet, this is not to scale, but somewhere between 50 and 675 is 300 feet. So I'm just going to say, maybe right here is 300 feet. So let's just see. The rocket's going to pass 300 feet, it's going to be above it, and it's going to pass 300 feet, and it's going to be below it again over here. So during this time interval, the rocket will be higher than 300 feet. We need to figure out what this time is and what this time is. We could do that analytically by setting the equation, S of t equal to 300, and solving for that. And this is a quadratic equation. We could totally do that. I'm going to want you to use your calculator so you can see how to use some of these buttons. So get out your calculator. I'm getting out my TI-84. And so what you should do is go to your Y equals screen. And you should have the y equals screen like that. Okay. Then what I would like you to do is next to y1, we're going to start typing in our equation. Our equation is negative 16t squared. So you want to when you lead with a negative, you want to use the negative that is at the very bottom, right, that key. If you use the minus sign, it'll say error. So don't use that one. So say negative 16. And then you want to hit your variable button, which is this button right here. It says x tau theta n is what it says. Press that one. And then if it's squared, you can either use your caret button and then 2, or you can simply hit the x squared button, which is what I just did. That x squared button right there. And so then I want to say plus 200 plus that same x tau theta n button x to get your x plus 50. And so this is what my screen looks like. Now we want to go, I want to be able to see this picture, and I want to be able to see 300 feet. So I'm going to go to the window, and I'm going to tell it what x values I want. So since it's time, and it goes only forward in time, and this is 6.25 seconds, maybe I'm going to go out maybe 20 seconds. And even though I know negative time doesn't make sense, I like to see a little buffer. So I'm going to let my x min, the furthest to the left, be negative 5. And then I'm going to have it go all the way to x max I'm going to put in as 20. And then the next thing I have is x scale. I just leave it at 1. I don't think I need to change that. Then y minimum. Default is negative 10, but I don't need negative values because that means below the ground. I just want a little buffer, so I'll say negative 5. And how high do I want it to go? Well, I want it to go at least 675 feet. That's the max. So I'm going to put in maybe 800 feet just so I have a little buffer. And instead of going a scale of 1, I'm going to have it jump by 10s. You don't have to. You can still have it to go by 1. And then I'm going to hit second quit, and then I'm going to hit graph. And hopefully I'll see my whole parabola. And so this is what my screen looks like. If you can see that. But I got my little parabola. That's what you want to be able to see. Now, what we're trying to calculate here, if we want to find the max, let's play with some buttons. Hit second and trace, which is calc, and you'll have a menu. It'll say value, 0, min, max, intersect, and I want the max. So select number 4, and then it's going to ask you a series of questions. It's going to say left bound, question mark, and my cursor is not. My cursor is right bound. I don't know if you can see it, but my cursor is on the right side of my parabola. So I'm going to move it with this button right here until it's clearly on the left side of my parabola. And then I'm going to hit enter. And then it's going to say right bound, and it's not. I have to move it with my right arrow till it's on the other side of my parabola. And I just did that so that it's on the right side. And now I'm going to hit enter. And then it says, do you want me to guess? And I'm like, yes. And so what my calculator is really good at doing is finding the maximum point when I asked it to do that. And so it did that, and that's how we got these numbers graphically. All right, now we want something else. We want to know for what time interval is the rocket above 300 feet. I'm going to hit second quit. I'm going to hit second calc, which gives me value, 0, min, max, intersect, that same menu of things. This time I'm interested in intersection. I want to know what this point is when the parabola intersects this line. So, oops. So I forgot to tell you something. Go to your y equals, and we have to introduce this line. Well, this is a horizontal line, y equals 300. So that's what I'm going to do. I'm going to go down to y2 and just say equals 300. And then when I hit graph, I'll have my parabola, and I'll have a line going across. And so this is what it looks like on mine. Okay, now I want to find this intersection and this intersection. So I'm going to go to second calc, and I'm going to select 5 because this is the intersect. And so it's going to ask me, am I on the first curve? And it's on the parabola, so that's my y1. I'll say yes. And then your calculator is great at this. It's going to switch to the other curve and say, am I on your second curve? It's on the line. I'm going to say yes. And then I'm going to say It says guess, and I'm going to say yes. And so my calculator was closer to this point, and so we found this point, and it says that the y value is, of course, 300, but the x value is 11.09 or 11.1 seconds is what this is. Okay. Now I'm going to do the same thing. So hit second quit, then I'm graph, go to second calc, and now I want to do intersection. So it is still sitting right here on this point. I don't want it to find that same point. It's just going to keep finding that all day long unless I tell it to go somewhere else. So I tell it I'm going to move left so that it's closer to this. So I'm going to use my left arrow button until it's really a lot closer to the intersection that I'm interested in using. And so I moved it, I don't know if you can see it, I hope you can, but I moved it really close to that side. So now I'll say enter, and then it says I'm on the second curve, and it went to my line. And I say yes, and I say guess, and it's going to find it for me. And so this tells me that the x-intercept is 1.4. 1.4 seconds. Okay, so let's answer this question. For what time interval will the rocket be more than 300 feet above ground level? And so this is when it's going to be more than 300 feet above ground level, between 1.4 and 11.1 seconds. Or 1.4 is less than t is less than 11.1 seconds. These are two different ways you could say it's above 300 feet. Now the last question. After how many seconds will the rocket hit the ground? This is asking us, when will the rocket hit the ground? What does t equal to? Well, we can use our calculator for that. I'm going to show you how you would do it analytically. Is you would set the position function equal to 0, and you would solve this quadratic equation, which you know how to do because we've already been doing tons of that. If you want to use your calculator for this, this is what you do. I'm going to go to my y equals screen, and I'm going to go down to y2 and hit clear, just so I don't have to see this 300 line anymore. I don't want to worry about that one. And what I want to know is when my parabola intersects the ground over there. So go to second calc. This is an x-intercept, and we've already learned that x-intercepts are called zeros. So look at your menu, there's something called 0. That's what I'm after. Select number 2, and it's going to ask you, am I the left side of your 0? So if it's on the parabola, you're on the left side of the 0, and once it goes below it, it's on the right side of it. Okay, so say yes, hit enter, because if it's anywhere up here, and it is, say yes, I'm on the left side. Now, what you want to do to tell it's on the right side is watch your y value, and once that goes negative, you know that it's crossed the x-axis. So I'm going to hit my right arrow till it goes, now mine's at negative 15.4, so it's underground basically. So I'm going to say yes, it's on the right side of my 0. And then it says, do you want me to guess? And I'm going to say yes. And so it's going to tell me that x is equal to 12.7 or 12.7 seconds is when it hits the ground. Now my y value doesn't say 0. It's my calculator doing the best it can. It says y is 1 times, it says e negative 10. 1 e negative 10, which means 1 times 10 to the negative 10, which is something very, very close to 0. That is trying to say 0. That it's ground level. So that's how you can find an x-intercept if you want to with your calculator. Alrighty.